So in this video, we're going to look at chapter 10 and 11, section 10.2 and 11.2, which is on paired data. So you want to find the page that says chapter 10 and 11, part 3, confidence intervals and hypothesis tests for paired data. So in this section, we are also going to look at means, but we're going to look at comparing means for paired data. And what paired data means is there's either a relationship between the two groups or the data is on the same group of people. And it's what we talked about at the beginning of 10.1. We're looking for dependent groups. There's some relationship between the groups. When we have paired data and are comparing the means, it's called a paired t-test. Another name for it is called matched pairs. So for this one, we're interested in the difference, and we use the following notation. So when we talk about the difference between the sample means, we do X bar again, but we put a little D by it to represent the difference. And so what that means is X bar D is really X1 bar minus X2 bar. Okay? It's the difference in the two means. And then when we talk about the difference in the sample standard deviations, we use SD, okay? And that is the sample standard deviation of the differences. And again, what it represents is really S1 minus S2, the difference between the two sample means. Now this you don't have on your packet. If you want to add it, you can, but mu D is the population mean difference for the matched pairs. And mu D is equal to mu1 minus mu2, the difference in the two means. Yeah. But I have that really just on the next slide in paragraph form if you don't want to add it. So it says it right here. We let mu1 and mu2 represent the population means, and then mu D represents the population mean of the difference. Mu D is equal to mu1 minus mu2. And the paired data reduced to a 2-sample problem to a 1-sample problem. So what we're going to do is we're going to run a T interval again, but we're going to run it on the difference between the sample means and the sample standard deviations. And we'll look at how we do that. So again, in order to do this, we have to be able to use a T distribution. And to do that, we have to have two conditions. So the first condition is we use this method when we have two paired random samples. Again, when we have two dependent samples. So that there has to be a relationship, such as like mother, daughter, spouses, siblings. There has to be a relationship, and each data value in the first sample is paired with a data value in the second sample. And then the sample size is large, so N has to be greater than 30. For this, the samples will always be the same size because they're paired. So N1 and N2 will both be greater than 30. If not, the differences between the matched pairs from a population has to be approximately normal. So if we have the list for the first group and a list for the second group, what we will do is in our calculator, we'll find the difference and we'll put it in L3. So we'll do L3 is L1 minus L2, and we'll check that L3 is approximately normal. And then we're going to do, again, hypothesis tests and confidence intervals. So we're going to start with confidence intervals, and we're going to look at the confidence interval and the difference in the means. And we put that difference in L3. So for confidence interval for paired data, most of the time we'll be given lists of data. If we're given lists of data, we put our first list in L1 and our second list in L2. And then we're going to highlight L3 and put L1 minus L2 to get the values in L3 so that you don't have to calculate them by hand, and I'll save you time. And then we're going to run a T interval again on L3. Okay, so let's look at an example. So the first example A group of 5 individuals with high blood pressure were given a new drug that was designed to lower blood pressure. Systolic blood pressure is measured before and after treatment for each individual. The results follow. Construct a 95% confidence interval for the mean reduction in systolic blood pressure. Okay, so when we have two groups and we're talking about means, the first thing we have to figure out is, are they paired or not? Because that's going to determine if we run this new test or if we run a 2-sample T interval that we talked about in 10.1. So in this case, because the data is on the same individuals, this is paired data. And when we have paired data, we run a paired test or a paired interval because we're doing confidence intervals. Okay? So to do that, what we do for this test is we are going to put both sets of data again. Okay, so we're going to go to L1 and enter our data in. And then we're going to do L2, which is the after treatment, and enter that data in. And always stop, take a minute, check all your values to make sure we did not type anything in wrong. Okay, so once we do that, we need the differences, and you could calculate all of them by hand. You could do 170 minus 145, but a quicker way, especially if we have long lists, is we can use our calculator to calculate the difference. So how we do that is we go up to L3, and we're gonna do L1 minus L2. So L1 and L2 again are in blue above the numbers. On minus blue, could be yellow. But I'm gonna hit second 1 to get L1 minus second 2 to get L2 and hit enter. And what it will do is it will subtract each L1 from the corresponding L2. So this is like 170 minus 145 is 25. 164 minus 132 is 32, and that's what it does. And so it does it all for you, so you don't have to actually do it by hand. And it's very useful, especially when you have a long list of data. So then from there, we run a T interval. So it's called a paired interval, but we run a T interval again, okay, because we have one list of data. So we're going to go to stat test. We're going to go down to T interval, which is number 8. And we are going to go to data because we've listed data, but we're going to change our list to L3 because we're going to do the test on the differences. So we're going to hit second 3 for L3. Frequency again is always 1. Confidence level matches up. And then we hit calculate. And so this again is the confidence interval for the differences between the means. So we get 22.335 and 40.465. Right, and so we're gonna interpret a little bit, even though it doesn't, well, it asks on yours to interpret the interval, but then also see if there's a difference between them. So for this, when we interpret it, it's very similar to how we did the 2-sample means. We would say we are 95% confident that the true difference in means of systolic blood pressure before and after treatment is between 22.335 and 40.465. So that's our interpretation. And then there might be a question like, is this treatment effective? Did it lower blood pressure? And so remember, this represents mu d, the difference, between mu1 and mu2. And so if we look, the difference between the first group and the second group is by 22.335 and 40.465. And so it means this first group is higher. So before treatment was higher and after treatment was lower. So we can say the treatment lowered blood pressure, or there's evidence that it lowered blood pressure because the entire interval is positive, which indicates before blood pressure was higher than the after blood pressure. And so again, if 0 is in my confidence interval, it indicates no difference. If my entire interval is positive, it indicates the first group is higher. If my entire interval is negative, it means the second group is higher. And then just make sure you're answering in the context. In this case, we want the first group, the blood pressures to be higher in the first group, because then that means the treatment is lower. So that's an example of confidence interval. And then we'll practice with this in class, the other example.